Good morning, student. Today I am going to discuss the second part of this electrochemistry series, that is determination of activity and activity coefficient. As you know that I am using the very important facilities of our Pandit Ravi Shankar Shukla University, Raipur, that is lecture capturing facilities. And I am really grateful to Professor Balwant Singh Thakur, head of the Department of Mathematics and in charge of this lecture capturing facility, and his colleague Dr. Dipti Thakur, Dr. Indra Kumar, as well as my student Abhishek Katendra for providing me all the facilities. Now, if you referred my first lecture regarding the fundamental concept of activity and activity coefficient, because you all know that if we consider any thermodynamic concept, so these two parameters are very, very important for studying the behavior of the phase equilibria or even chemical equilibria, electrochemistry for non-ideal reason. Because if we consider the ideal system, in most of the cases, the activity is exactly equal to the stoichiometric concentration. But you know that most of the systems are non-ideal. So therefore, there is a deviation concentration. So that is to be determined. And there are many methods available in the literature. And it is very important because singly we cannot determine the activity coefficient of cation or activity coefficient of the anion. So the general procedure is that the determination of mean ionic activity coefficient or mean activity like that, mean molality like that. So in this presentation, I will discuss the most popular method, which is very important for the examination point of view as well as for the fundamental knowledge. And it is the course of M.Sc. first semester chemistry syllabus. Now, as you know that whenever I deliver any lecture, I refer large number of books for the student. And if you are interested in complete methodology, complete method, because there are a large number of methods, so you can refer these books, and I will try to explain the math, the derivation, very simple manner. But if you have any doubt regarding this derivation, you can refer this book. My most favorite book, Physical Chemistry by Ira and Levine, Indian edition. And another book I always prefer, that is Thermodynamics for Chemists by Glaston. And in addition to these two books, I have also referred to more books, that is Physical Chemistry at Keen, and another very popular book, Physical Chemistry by Silve, Alberti and Bawendi. For exact definition of, sometimes students get confused, what is actually activity and activity coefficient and how it is determined. Now, as you know that activities and activities can also be calculated for the non-electrolyte or some solvents, but bear in mind that I am dealing with the electrochemistry and talking about the electrolytes. So therefore, it is the electrolytes. I'll explain that how it. So if I take one electrolyte and this mu plus and mu minus means the number of cations and number of anions after the ionization form. Of course, the valency is different. If you ask me, sir, what is the actual definition of that activity? Although in my first lecture, I have given very detailed information, but here you can write that it is an effective concentration of chemical species, of course, for non-ideal interaction. Because as I told you that if it is a dilute solution and real solution where Raoult law is followed, so there is no distinction between the activity and the stoichiometric concentration. It can be explained in terms of molality or in mole fraction. But if I take the non-ideal, the concentrated solution अगर लिया जाता है, तो there is उसमें एक विचलन होता है, एक डेविएशन होता है. जनरली if it is a solution अगर बहुत तनु है तो activity coefficient is equal to 1. लेकिन जैसे हम विलायन को कॉन्सेंट्रेट करेंगे तो आप देखेंगे कि वहाँ पे डेविएशन होता है, and that is called the apportion deviation from the ideal equally to the cations and anions. And basically मैं उसको I can write that activity is equal to molality and the activity coefficient gamma. And then now it comes to the determination of the system. Now you know that if you see your syllabi, prospectus of first semester chemistry, तो आप देखेंगे कि उसमें लिखा हुआ है determination of activity and activity coefficient. So I have just categorized in the two methods. One is experimental method. Another second is that theoretical or the analytical method. Now, what is the difference between these two methods? Now, if I am talking about the theoretical method, you all know you have already studied the Debye-Huckel theory in detail, and I have also prepared many lectures for the Debye-Huckel theory. And you know that there is a very good correlation between the activity coefficient and the ionic strength of the solution. So if you know the formula of the Debye-Huckel theory, तो आप उस Debye-Huckel theory की मदद से activity coefficient निकाल सकते. If you know the strength, concentration, the electrolyte, ionic strength, निकाल सकते हैं. So similarly, there is a extended Debye-Huckel theory, Davies equation. दूसरे तरह के जो मेथड्स है जिसको हम लोग बोलते हैं एक्सपेरिमेंटल मेथड, विच इज वेरी सिंपल. सो एंड above all this method, the most important method is the electromotive force EMF measurement. That means we have to construct a cell and then measure the EMF with different electrolytes. So that is the most important method. So today I will discuss this method in detail. And second is that also you know that there are different types of electrochemical cells. Chemical cell, concentration cell with transparence, without transparence. So first method is electromotive cell, where we will take a single simple standard hydrogen electrode लेंगे और एक सिल्वर क्लोराइड इलेक्ट्रोड लेंगे, एक सेल बनाएंगे एंड उसमें हाइड्रोक्लोरिक एसिड की कॉन्सेंट्रेशन को मोलालिटी को अलग अलग चेंज करेंगे एंड वी मेजर दी cell EMF, and there is a formula. With that formula we can determine. But there is another method that is called the activities from the concentration cell with transparence. And there are many colligative properties methods like vapor pressure, osmometry, freezing point depression, boiling point elevation, solubility measurement, spectroscopic method. But today in this particular lecture I will concentrate only on the first method, that is the EMF method. As I already told you, these methods is available most of the physical chemistry book. में ये मेथड अवेलेबल है. अब बिफोर गोइंग इनटू डिटेल्स ऑफ द डेरिवेशन, आई विल जस्ट talk about the what is actually mean ionic activity coefficient, what is mean molality. For that, now, so for example, if I take again, I am taking a electrolyte. Yes. So X, you know. So mu of cation is Z plus, then X is Z negative. So basically, if I want to calculate the activity first, so I can write, I have already given this thing, because there is a formula, the chemical potential of this. For cation, I can write like that. Standard state plus RT is a very well known formula. Similarly, chemical potential of anion and this. This is actually activity, which is very important. But basically, as per the norms, activity is equal to concentration, and here activity coefficient I can write that. Yeah. Or if I am taking in terms of molality, so I should write M. But here actually there is cation and anion. So for, if I take like activity, you know that A plus, U plus, A minus, B minus. And similarly for, if it is a cation, so I can write like this, M and gamma. If it is plus, so I can write that this plus. Now if I write negative, so M negative, gamma negative. But if I take A plus minus, so that is mu plus minus is equal to M plus minus gamma plus minus, you can write that mu negative plus minus plus minus. Or simply I can write here also that if I write gamma plus minus plus minus is equal to mu activity coefficient, here it is actually u plus gamma mu minus. So this is actually mean ionic activity which we have to determine. So if I just write here mu plus minus is equal to, you know, very simple, that I can write like that, mu plus minus, and this eraser, where is eraser? Eraser. Yes. So I can write 1 by mu plus minus. Similarly, if I write mean molality, that is also like that, M plus minus is equal to M plus mu plus M minus mu minus 1 by mu plus minus. So if I take, suppose I am taking a barium chloride solution, so I can write that if it is a barium chloride, so it is barium is 1, and here is also 1. If it is chloride, 2, Bl2 2, and 1 by 3, that is plus minus like that. So if you want to go into details, you just follow my first part of this lecture where I have discussed it. Now I am going to the actual determination of mean ionic activity coefficient by the EMF method. Okay. Yes. Please listen it very carefully. Now I'll give you some example also. Now the first part. Here our objective is that determination of mean ionic activity coefficient of electrolyte. So for example, here I just want to calculate the activity coefficient of hydrochloric acid, HCl. And as a reference, I have taken the molality of that is M. So first, I have to construct a electrochemical cell. You can see here, the conductor I am taking a platinum and I am taking a hydrogen electrode, standard hydrogen electrode, dipped in a pressure is 1 atmosphere or 1 bar, dipped in a hydrochloric acid whose molarity is M. And another is silver chloride and silver. You are aware of the electrochemistry, you know the cell reactions and other things, which is anode, which one is cathode, where oxidation takes place, where the reduction takes place. In this case, this is oxidation takes place in anode, which is negative electrode, where hydrogen is oxidized. Hydrogen is oxidized. So half H2 gas is equal to hydrogen and plus loss of electron, you know, that is oxidation. And second part is the cathode, or where the reduction takes place. Here the silver and silver chloride electrode. So silver chloride is reduced. It accepts the electron. So AgCl, solid Ag and Cl. So in undergraduate classes we generally know, first we write cell reaction is the oxidation as well as the reduction. So then we will write the complete cell reaction in my second transference. It is very undergraduate level thing. So again I am writing the same thing. You can also, 2 electron process is also process. You can write also H2 is equal to 2H plus 2 electrons. But simply we have taken half H2, then hydrogen, and this is the anodic reaction, this is the cathodic reaction. So what we do, we just sum it, add it. So if I add means if I just add it. So this is H2, half H2, of course here. Then this silver chloride, AgCl. And then of course it is Cl, just like Cl negative, aqua. So then Ag, and this is the hydrochloric acid. Why I am written M? Because I assume that the molality of that solution M. So our final reaction is that AgCl. Now it is a very simple. You know the Nernst equation. So I have to apply this Nernst equation. You know that Nernst equation is very simple. Is equal to E0 minus RTNF, natural log of this, if I write Q1 and Q2 like that. So here is, I can write the activity of the HCl, and then we separate the activity into molarity and activity coefficient. So if you follow this point, this is a very simple cell reaction. Now I'll write the Nernst equation. I'll write the Nernst equation. No. I just have to second PPT. Yes. So now you first again I am writing the cell. This is H21 atmosphere. This is the cell. So you know that standard cell potential E right minus E left, E oxidation, E reduction minus E oxidation. But here, because you know that it is a pure gas 1 atmosphere and it is solid, so while writing the cell reaction, we will omit this solid state and gaseous state like that. See here, if I write this thing, so I must write E is equal to E0, which is very important. How I determine the E0, I'll tell you. That is the standard EMF between this reduced part and the oxidized part. E0 minus RT, R you all know, universal gas constant. N is the number of electron change. Here is 1. Here is 1. So I must write the natural log of activity of HCl, of course molarity, divided by H2O half and then activity of silver chloride. But why I am omitting all these things? Because in hydrogen ये गैस है, इसलिए हमने उसको नहीं कंसीडर कर रहे हैं, और सिल्वर क्लोराइड जो है वो सॉलिड है, इसलिए हम इसको कंसीडर नहीं कर रहे हैं. तो हमको क्या फॉर्मूला केवल मिल रहा है, E इज इक्वल टू E0 माइनस RT, N इज इक्वल टू 1, नंबर ऑफ इलेक्ट्रॉन चेंज इज 1 and activity of HCl. That is I am getting. Okay. So next, again I have to. Yes. So you see here, again I am getting E is equal to E0, RT, NF and only HCl. We know that activity is equal to molarity and activity coefficient, because there are two ions, hydrogen ion and the chloride ion. So I can write like that, M plus minus, gamma plus minus, or I can write the separately, because in first case activity of hydrogen, so I can write M of hydrogen ion or gamma of hydrogen ion. So there is no problem. You can write first gamma hydrogen ion plus, or even you can write simply plus. So you have written here, I have written here, E is equal to E0, RT NF, natural log of, this is for hydrogen and this is for, why I have taken, because our concentration is M. So now I am just separating these things. Separating these things, you know. First is again, it's a very simple, graduate level. Again E, suppose I am taking 5 different hydrochloric acid solutions. So I will get, अगर मैंने 5 डिफरेंट मोलैरिटी के हाइड्रोक्लोरिक एसिड का विलयन लिया तो हमको 5 सेल ईएमएफ प्राप्त होगा. बाकी कॉन्सेंट्रेशन आपके हाथ में है. बट हाउ टू कैलकुलेट E0 वो मैं आपको इसके बाद में बताऊंगा. तो ये देखिए गैमा एंड दिस. बट आवर ऑब्जेक्टिव इज दैट to determine, our objective is to determine the mean ionic activity coefficient. Suppose if I am taking this mean ionic activity. So it is mu plus minus. And generally I am taking the uni electrolyte. So it must be here it is 2. One hydrogen, it is 2. It is 2. So therefore I can slightly modify that equation. And second, what I am doing, I am using, in one cases I am using that molarity of HCl, and another cases I am using the activity coefficient of hydrogen and activity coefficient of chloride ion. But I have to determine the mean activity coefficient. So I have to slightly modify that equation in terms of mean ionic activity coefficient. So let me. So as you know that we know the Nernst equation, there is no problem, but here I am using mean ionic I am using mean molarity, but here actually same cation and anion molarity, so therefore I can use M, but activity coefficient is different. So if I take suppose if I take two, because here is uni electrode hydrogen and mu plus 1, mu minus 1, 1 plus 2. If I take log of, so it will be 2 natural log of plus minus 1. So I think you can now understand why I have written here 2, but earlier it was simply RT by NS. From where I get this 2, because this is mean molality like that, but here because cation and anion concentration is M, so therefore I have not changed here M. But here actually now it is actually mean ionic activity coefficient, which is our objective, how to determine this mean ionic activity. And second thing, how to determine the EZ. So that is, now final equation is E is equal to E0 minus 2RT, 2 from here, now it is mean molality, or you can, in some books it is written like mean molar ionic activity. So there is no problem. You can directly write the mean ionic activity coefficient. So now just if I rearrange this equation, अब इसको बहुत थोड़ा ध्यान से देखिए क्योंकि फाइनल इक्वेशन आ रहा है, और अगर आप मोलारिटी की वैल्यूज मालूम है, आपको E0 की वैल्यू मालूम है, तो आप लॉग ऑफ एक्टिविटी कोएफिशिएंट भी आप निकाल सकते हैं. Now the last part of this is very important. इसको बहुत ध्यान से आप देखिए. Again I am writing same thing. That E is equal to E0 2RTN. I can rearrange this equation. What I can do, I can write like that: E minus E0. So I think E, अगर हम इस E0 को यहाँ पे ले आएंगे तो क्या हो जाएगा? E माइनस E0 हो जाएगा. इसको हम यहाँ पे ले आएंगे तो ये माइनस की जगह ये प्लस हो जाएगा. तो क्या हमारे पास बच रहा है? -2RT नेचुरल लॉग ऑफ. देयरफॉर आई हैव जस्ट, शुरू में आपको मैं 2-3 बुक्स दिखाया. यू जस्ट शो मी दैट बुक, थर्मोडायनामिक्स फॉर ग्लास सेंसर्स. गिव मी दिस बुक. Yeah. Don't get confused, don't get confused because I'm just using the very simple book, Physical Thermodynamics for Chemists. And there are many type of the derivation, but ultimate result, ultimate equation must be equal. तो आप अलग अलग ढंग से भी आप कर सकते हो. That means आप ऐसा भी लिख सकते हो कि just you see same equation, nothing new. हमने क्या किया, E is equal to E0 minus 2RT natural log of M is this. So just I rearrange this equation. इसको हमने यहाँ ले गए, ये माइनस हो गए, इसको हम यहाँ ले गए, ये प्लस हो गए, as it is that. Or I can write like that. You see, E plus same thing. There is no difference like that. So this expression can be used for the determination of mean ionic activity coefficient in a hydrochloric acid solution from a measurement of cell EMF E. But there is a problem that how you calculate the E0. How you calculate the E0. Now, if I just slightly rearrange this equation, I can write like that: E0 plus 2RTF natural log of M is equal to E0 plus E0. That means if we plot a graph between the different types of this part and M, so that from that intercept that E0 can be calculated. अब मैं उस पार्ट को आपको दिखाता हूँ. This is the final equation with that. But you know that there are different types of electrolyte, univalent electrolytes. Temperature may be different, your solvent may be different, and you know that there are different types of Debye-Huckel equation for dilute solution, for concentrated solution, extended Debye-Huckel theory. So I have to now apply the Debye-Huckel theory. Now if I ask you, because I have already, मैंने आपको Debye-Huckel theory को बहुत अच्छे से पढ़ाया है, मैं अगर आपको ये बताऊं कि natural log of plus minus is equal to sometime or minus natural log is minus 0.509 ZA ZB under root of mu. That is also normal form of the Debye-Huckel equation. So, or even I can write like that: minus natural log of plus minus is equal to 0.5. It is a value, constant value at for univalent electrolyte. Solvent is water, temperature is 25 degrees centigrade. So I can substitute the value of natural log of gamma plus minus. So now after this final equation, I have to substitute the value of Debye-Huckel limiting law in that equation. But question arises that which type of Debye-Huckel equation we can use? It is the extended form of Debye-Huckel limiting law. Let me just. So this is the last part. Yes. So again I am writing the same equation. मैंने आप देख रहा हूँ मैं बार बार उसी इक्वेशन को आपको लिख रहा हूँ ताकि आपको समझ में आ जाए. एकदम सिंपल इक्वेशन है. वही देखिए, E plus 2RTNF natural log of M minus E0, and our objective is to determine that E0 by extrapolation method. That means क्योंकि मैंने फिर से आपको एक बार समझा रहा हूँ कि आपने 4 या 5 हाइड्रोक्लोरिक एसिड का अलग अलग सोल्यूशन ले लिया और हर का सेल ईएमएफ आप निकलेंगे. ये एक्सपेरिमेंटली डिटरमाइन क्वांटिटी. M you know, E0 you have to determine by extrapolation method where M is equal to 0. उस वैल्यू को हमको सब्स्टिट्यूट करना है. So now you know that if I take R universal gas constant in terms of Joule, temperature is 298 and F is 96500. You know the values of the Coulomb, 1 Faraday, 965 Coulomb, and generally we will get 0.509. अपने अगर नॉस इक्वेशन को देखता हूँ, E0 को E minus 0.509 divided by N natural log of M. But here because there is a 2, so इफ आई सॉल्व इट, आप सोचेंगे ये वैल्यू कहां से आ गया, 0.1183 कहां से आ गया, सब्स्टिट्यूटिंग द वैल्यू ऑफ आर 8.314 जूल, टी 298 25 डिग्री सेंटीग्रेड, एफ 96500। तो ये इस पूरे का ये वैल्यू रेड कर दीजिए, ओके, डोंट वरी। So we use this value is 0.1183. Same thing here is also at 25 degrees centigrade, of course. Universal gas constant F is 96500. So we'll get this thing. इसलिए मैंने इसको थोड़ा हाईलाइट किया हूँ, और फाइनल इक्वेशन करीब करीब आ गया है, E plus 0.1. Now, as I told you that I have to substitute the value of this activity coefficient using Debye-Huckel limiting law or Debye-Huckel extended form and like that. So there are two forms, for normal system, natural log of plus minus is a 0.509 and ZA ZB under root of mu ionic strength I. Here is Z is 1 hydrogen ion, and so univalent valence is 1 multiplied by 1 chloride ion. So no question. But if I modified that equation, extended form, so that is natural log of this A is this 0.509. A is a constant. We can determine. जब आप अगर Debye-Huckel अगर इक्वेशन तो A की वैल्यू हम लोग निकालते हैं वाटर में थिकनेस ऑफ द आयनिक एटमॉस्फेयर। आप याद करिए कि 0.509. M is this molarity, it is under root of M plus, because this is appreciable concentration, that is also a empirical constant. कुछ बुक्स में आप डायरेक्ट Debye-Huckel limiting law की वैल्यू को डाल सकते हैं, but again I am telling that I am following the books of that Ira and Levine, and as well as the thermodynamics for chemists like Gaston. So I am just following their method, and this is the simplest method. बहुत ही सिंपल वे में मैं आपको समझा रहा हूँ। तो जब हम इस वैल्यूज को यहाँ पे रख देंगे तो इन प्लेस यहाँ पे आप लिख सकते हैं, यहाँ पे जिसके जगह में आप पूरा लिख सकते हैं माइनस A under root of M plus CM. You can write these things. But because here I am using 0.1183, it is multiplied by this 0.1183 multiplied by 0.1183 multiplied by 0.509, because it is, or I can write like that. So what I will get, this 0.1183 multiplied by 0.1183, 0.509, so it will get the 0.0602 under root of n. And as it is, same thing, E0, like that. I have just, why it is negative? Because I just change it here. So now, since system is very simple, that if I plot a graph between this y, complete is y, and concentration of this. Y is equal to mx plus c. So this is actually completely m, because state line is y is equal to mx plus c. So I plot a graph between m and this y part, different types. Suppose this is 0.5 or 0.1, 0.2, like that, 0.2 to 4. This is m, different molality from 0, 1, 2, 3. If I extrapolate this thing, extrapolate means मैं अगर इसको यहाँ पे ले आऊंगा, ये जीरो कॉन्सेंट्रेशन हुआ मोलारिटी में, तो दैट विल गिव द वैल्यू ऑफ E0. अगर आप E0 की वैल्यू जान सकते हैं तो फिर वो जो मेरा जो मेन फॉर्मूला था, इफ यू नो द वैल्यू ऑफ E0 एंड E, so you will get this natural log with this divided by this, like that. It can be very easily calculated. So only thing is that extrapolation value, if you plot a graph between this left hand side equation complete, that is suppose y, and then with the m you can get. And for hydrochloric acid, the value of E0, if I am not wrong, it is 0.224 volt, and it is given in these books of, I have given the source, thermodynamics for chemists by S. Glassman, page number 394. And of course, it is also available in the books of Alberti Daniels as well as other books. But I am just blindly following that book. So by that equation, you can directly determine E0 by extrapolation method. But जिन स्टूडेंट को ये समझने में तकलीफ हो रहा है, उनके लिए एक सिंपल मेथड भी मैं बताना चाहूँगा. देखिए, जिनको कठिन डेरिवेशन समझ में नहीं आता है, तो मैं उसको एक सिंपल मेथड आपको बता रहा हूँ. दैट मीन्स इफ यू नो द नॉन्स इक्वेशन, दैट इज E is equal to E0 minus RT NS. हमने 2 इसलिए कर दिया क्योंकि नेचुरल लॉग ऑफ m प्लस माइनस गैमा प्लस माइनस, और इवन आई कैन राइट लाइक दैट. इसको अगर हम डिटेल्स में लिखेंगे तो E is equal to E0 minus 2RT natural log of m minus natural log of gamma plus minus. Or if I just rearrange this equation, that means इस नेचुरल लॉग m को हम इधर ले आएंगे तो हमारे पास क्या बच रहा है, ये बच रहा है E. आप बोलेंगे सर ये कहां से आ गया, बिकॉज आई यूज दैट natural log of gamma plus minus is equal to 0.509, सारे को कांस्टेंट करके 0.509 a under root of m3 like that. So ये वैल्यू आ गया. So if I again फिर उसी बात को मैं कर रहा हूँ, again I plot a graph between, यहाँ पे अगर थोड़ा अलग भी कर सकता है, अंडर रूट ऑफ m, उसमें हमने m से की निकाला था, इसमें ये निकाले. अगर अंडर रूट हो जाएगा तो ये ऐसा हो सकता है, ऐसा आएगा. बट हमारा एक्सट्रापोलेशन वैल्यू में आपको निकालना है, इसकी वैल्यू निकालना है, E0 की वैल्यू निकालना है. वंस यू गेट दैट E0 वैल्यू, देन हमारा जो मेन इक्वेशन है, नेचुरल लॉग ऑफ एक्टिविटी कोएफिशिएंट इज इक्वल टू F by RT E0 minus E and natural log of m. So by that method, one can determine the mean activity coefficient of any electrolytes. So let me summarize. आपको अगर समझ में नहीं आया मैं फिर से आपको बताऊं कि पहले यू प्रिपेयर ए सीरीज ऑफ इलेक्ट्रोलाइट सोल्यूशन. आपने बना लिया 4-5 सोल्यूशन आपने बना लिया. देन आपका सेल कॉन्स्ट्रक्ट हो गया. यू मेजर दी सेल ईएमएफ. अलग अलग कॉन्सेंट्रेशन है, आपका सेल ईएमएफ अलग आएगा. कैन अप्लाई योर सिंपल इक्वेशन. एक्सपेरिमेंटली डिटरमाइन वैल्यू. एम आपके हाथ में है, सेल ईएमएफ आपके हाथ में है. E0 जिसको स्टैंडर्ड ईएमएफ बोला जाता है जिस दो इलेक्ट्रोड का, उसको हम क्योंकि M0 में हमको निकालना है तो एक्सट्रापोलेशन से हमने निकाल लिया. वंस यू गेट दिस E0 वैल्यू फ्रॉम द इंटरसेप्ट, then substitute all the values in that equation. So you will get the values of mean ionic activity coefficient. अभी मैं कुछ एग्जाम्पल आपको दिखा रहा हूं. Now again and again if you see the any book, any physical chemistry book जो मैंने आपको रेफरेंस दिया, आप डेरिवेशन के बाद आप देखेंगे. Here I am just showing you some of the values. Even if you see the books of this that Selvi and Alberti, Bavendi or even Levine, you will get the values. मैं कुछ रिसर्च पेपर भी आपको दिखाऊंगा. तो जैसा कि मैंने आपको बताया कि अगर सोल्यूशन बहुत डाइल्यूट है, ideal solution, so you see that if the molarity of HCl is 0.003213, so it is 0.939. So there is a deviation. It is almost 1. But if I take the concentration 0.0091, फिर उससे कॉन्सेंट्रेट किया, फिर उससे कॉन्सेंट्रेट किया, तो आप देखिए डेविएशन हो रहा है. So it is, if I plot a graph between the mean ionic activity coefficient and the molarity, so sometimes I will get, I will show you the graph. आप देखेंगे इस तरह से अगर आप चाहेंगे तो ये जितना लो होगा वहाँ पे अगर ये if it is 1, suppose it is 0.8 like 0.7 like that, what I mean to, आपको दिखेगा ये होगा फिर इस तरह से आएगा. I am giving only one example. Oh, there are a large number of examples. Any electrolyte, lithium chloride, sodium chloride, potassium chloride. I am just only giving one example of hydrochloric acid. Second, and there are many very good research papers are also. In my first lecture, मैंने आपको बताया कि G.N. Lewis introduced the concept of the activity and activity coefficient. And they have also determined the activity coefficient of the strong electrolytes, many electrolytes. So similarly, if you see the large number of research papers, Journal of Physical Chemistry, mean activity coefficient of the electrolyte solution, published in a very good journal, Journal of Physical Chemistry B, by same EMF method, and the results are like that. You see, there are a large number of examples. So how meticulously they, मैं just केवल आप लोग को स्टूडेंट को, you are not research scholar, you are M.Sc student, you must know the deviations and the activities. So therefore I am just for clarity and novelty मैं आपको दिखाना चाह रहा हूँ कि देखिए कितने डाइल्यूट अगर सोल्यूशन है 10 to the power -4 m, तो उसकी वैल्यू देखिए 0.988 और 0.989 लाइक 1. और जैसे ही मैं इसको कॉन्सेंट्रेट करते जाऊंगा डेविएशन हो रहा है एक्टिविटी कोफिशिएंट का, ये 0.83, 0.82 लाइक दैट. Similarly, it is for univalent electrolyte. Similarly, you see that for zinc sulfate or even manganese sulfate or even other nickel sulfate, magnesium sulfate, everywhere you see that the solution is higher, 1. So there is deviation 0.043, where it is close to 0. So ये वैल्यूज आपको बुक्स में भी मिल जाएंगे. लास्ट पार्ट ये हो गया कि नाउ आई डिस्कस अबाउट दी ओनली हाइड्रोक्लोरिक एसिड वेयर मोलरिटी इज m. सपोज you want to determine the potassium chloride or you want to determine zinc sulfate. So the common formula is like that. First, you have to formulate a cell. Like in that case, I have taken the standard hydrogen electrode and of course a platinum where is there as conductor, and another cell is silver chloride and silver. So suppose आपके कोई electrolyte है, each of these two electrodes is reversible with respect to one anion. So ये M and M plus. Then you see the formula is same formula. E is equal to E0 minus RT natural log A plus A activity of that particular electrolyte. When I write the mean, so then again जैसे कि मैंने आपको बताया कि यहाँ पे 2 हम इसलिए लिखा क्योंकि because here is nu is, why I have not written here 2, because it is not uni electrolyte. अगर आपने ले लिया कैल्शियम क्लोराइड CaCl2 तो आपका फॉर्मूला बदल जाएगा. Cl2 is 2 and calcium is 1, तो ये न्यू की वैल्यू क्या हो जाएगा या 3. आपने दूसरा ले लिया मैग्नीशियम फॉस्फेट Mg3PO4 twice, Mg3PO4 twice, तो Mg3 में 3 मैग्नीशियम, PO4 में 2, तो यहाँ हो जाएगा 5 like that. So initially, but there will be no change in formula. So again, same thing, E is equal to E0 minus nu RT NF natural log of M plus minus. You can write simply M, and here is the activity coefficient. So friends, I hope that you really, because it is not at all difficult, but you have to derive this equation for univalent. Just I derived using the hydrochloric acid, and similarly any types of electrolyte can be determined by this is the simplest method, and I hope if time permits in next class I will discuss the other methods also. But this method is very popular, and in any M.Sc chemistry laboratory having with all the electrochemical setup, they can determine the EMF method for the activity, mean ionic activity coefficient. And I suggest you that please refer all these good books where there are a large number of numerical problems are there. If you solve the numerical problems, so then you can understand very well. So thank you very much. So again, I am thankful to Mr. Balwant Thakur and his group, because in this new year 2026, I am using this lecture capturing theatre. Thank you very much. And I am also thankful to my students Abhishek Patendre for preparing some slides and some diagrams and other things. Thank you very much. Thank you.